going to finish up what the book has in lesson 43. We already know our basic SOHCAHTOA definitions for sine, cosine, and tangent. And we know if we have an angle and we have the sides labeled, how to use that to find the ratios. What we're going to do today is, if we have the ratio, can we find the angle with the help of the calculator? So inverse trig functions are when we want to find the angle. We already know the ratio, but we want to find what the angle is. So if I want to find an angle whose tangent is 0.405, that means I want the tangent of some angle to be 0.405. So I have an angle, I take the tangent of it, and I get a number. Now I want to do something to that number to get back to the angle, so I want to undo taking the tangent and get back to the angle. That is all that inverses are. Our notation for the inverse is going to be tan with what looks like an exponent of -1. I want to take the inverse tangent so that that will undo this, and I will just have my angle. So if I take the inverse tangent on the left, I have to take the inverse tangent of whatever is on the right. You're going to very quickly get to where you aren't writing it out like this. You just write inverse tan of 0.405. I need to point out this is not 1 over 0.405. It is not 1 over the tangent of 0.405. It means the angle whose tangent is. So to find that, we simply punch that into our calculators. So let me model that on this first one. So we get on a calculator page or scratch pad. We're still going to use the trig button right beside the number 7. So when I do that here, I get all of these choices that come up, and I simply want to find the one that says tan -1. So the inverse tan, and then inside the parentheses, I need to type the number that I had, which was 0.405. And push enter, and it tells me that my angle is 22.048. And that is degrees. Anybody with a question there? Okay, let's try another one. I've got that on the same slide here. Okay, this time we want the angle whose sine is 0.794. The angle whose sine is 0.794 looks like that. And as you get comfortable with this notation, you may start writing it like that we're trying to find this angle. If you aren't quite sure, you write down the sine of the angle is 0.794. Oh, I need to get rid of the sine, so I have just the angle. So to get rid of sine, I need to take the inverse sine. And if I do that on one side, I do that on both sides. And raise your hand when you have typed this in on your calculator. Madeline, what'd you come up with? And we label it degrees since it is the measure of an angle. Thumbs up, thumbs down. How do we feel here? Let's do a couple more. Sometimes we will have these with a fraction instead of a decimal. That means maybe we had our triangle, and here was our theta. Sine was opposite over hypotenuse, so we had this. We could figure out the other side if we wanted to, but this one isn't asking us for that missing side. It is asking us what is the angle. So type in on your calculators what you think you need to do. You'll simply have a fraction inside the parentheses. I took the inverse sine of both sides. That would cancel out on the left, and I just have theta, and raise your hand when you have typed that in on your calculator. Ethan, what'd you get? Thumbs up, thumbs down. Anybody else getting that? So I think we've pretty much got the idea. Let's do one more on here. This time I won't write anything down. You just do it. Figure out what you need to type in on your calculator. And raise your hand when you have that answer. Austin, what do you have? And what did you type in on your calculator? Tangent tan inverse is how we read that, of 3. Inverse tan of 3. Must have this on your paper because you type in your calculator tan inverse 3. Anytime you pick up a calculator, you have to have on your paper, this is how I type it in the calculator. So this must be on there to show me what you typed in on the calculator. Questions from anybody on this today? Going to pause for a moment. Okay, let's talk about number 8, what I would like for you to do on that. So you've got 3 triangles, and so one of them uses the first triangle, one the second, one the third. I'm just going to talk about that first triangle. So it looks something like, let's see, A's down here, and then I have 7.6 on the hypotenuse, 5 over on the left, and 5.74 at the bottom, and my right angle here. And question A asks me for the sine of A. So first, SOHCAHTOA sine is what with adjacent hypotenuse opposite? Melissa? So I need opposite over hypotenuse. So who can tell me the numbers for opposite and for hypotenuse? McKenna? Okay, now that's a fraction inside of a fraction because decimals are just one way of writing a fraction. So it's a complex fraction. In other words, you can't have decimals inside of fractions. So first thing I want you to do is to get rid of the decimal. And if I have 1 decimal place, I'm going to multiply by 10 over 10. If I have 2 decimal places, I'll multiply by 100 over 100. So 50 over 76. Can that be reduced? Yeah, both things are even. So the next thing I want you to do is to reduce that. And then I want you to give me the decimal. But the book said 2 places. How many do we always use? So you're going to reduce it as a fraction, and then you're going to get it as a decimal with 3 places, not 2, on all of those parts of 8. Questions on those instructions?